Greetings, programs. Let's talk about AI. The warning, this presentation will be expired in 3 weeks. I was updating slides this morning. It was great. If you want the slides, they will go by fast. You can get them at wherecanigettheslides.com. All right, let's talk. Obviously, you can't sneeze without hitting something about artificial intelligence, about language models in general. So today we're going to dig into what all this stuff is. If you're unfamiliar, like I doubt anyone in this room is, but there's a lot of different ways to access these now. So there's, of course, OpenAI, Google Bard. You have generative search experiments in Google, where Google is now putting summarization into search results. If you work in SEO, this is a problem. You have Bing, of course. You have Claude. You have open source systems like GPT for All, which we'll talk about in a bit. When we talk about large language models, model's a fancy word for software. When you hear model, it's software. In the same way that Microsoft Word is software made by humans for humans, a model is software made by AI for AI. This is important because a lot of the things we talk about, like Bing and Bard, those are interfaces to models. This is going to become really important as we see an explosion of these new models. The interface is like, the steering wheel of your car. The model is the engine, and they can be swapped out. What is this stuff? What is a large language model? All of this starts from a quote from 1957 by John Rupert Firth, a specialist in linguistics, who said, "You shall know a word by the company it keeps." You shall know a word by the company it keeps. If I say, I'm brewing the tea, for most English speakers, it's pretty apparent that I'm talking about a beverage made of hot water and a dried leaf. Now, if I say, I'm spilling the tea, this is different. One word changes the meaning of another word. There are statistical distributions in how words work. Right? We all know this from the language that we use. If I say, I pledge allegiance to the next logical word is. If I say, God save the, or king, a lot of you need to update your databases. You know these statistical representations. That's what language models are. They are nothing more than big statistical databases. Here's how they work. This is the unhelpful version. This is from 2017. This is a paper called Attention is All You Need. We will not get into the mathematics of this. It's not fun, and it's only 8:30. Imagine text, lots and lots of text from all over the place. Imagine text as a pizza, right? And your cookbook is a model. The way these things are constructed is a company like Anthropic or Google or Facebook or OpenAI goes around the world and eats every possible pizza, right? In addition to being violently ill, they're taking notes. And when they're done, all those notes get collated into a cookbook, right? The model is the cookbook, which is important because if you've ever done any cooking, you know that there's no actual food in a cookbook, right? It's just recipes for how you can make your own food. And then when you ask a model, tell me how to make a pizza, it will spit out some understanding, even if the pizza is something that you've never heard of before. That's how these things work. They take enormous amounts of data, mostly text, ingest them, summarize them down to mathematical distributions, and then when you talk to them through an interface, they spit out what they remember from the notes. The original text is not in the model. Really important. Ask it for creamed corn and mushroom pizza or pineapple and mushroom pizza. Now, you can argue about whether pineapple belongs in pizza or not, but the models know it because they've probably seen it or some variation of it. Right? That's how these language models work. They are nothing more than libraries of probabilities, guessing what's next.